Good morning, all of you. How are you all? Hope you all are fine. In last class, we have discussed about force and types of forces. Now we are going to discuss about pressure. It is an important physical quantity. Do you like to help your mother in the kitchen? Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? Have you ever seen potters place a round piece of cloth on their head when they are carrying heavy loads? At the end of this lesson, you may understand the reason for this. Let's start with pressure. The intensity of force on any object depends upon the area of application and the force applied. This is known as pressure. Simply, we can say that pressure is the force applied per unit area. Do you know what is area? Area is the space occupied by an object. Units of pressure. SI unit of pressure is Pascal. SI, what is SI? System International Unit. It is an organization. From the definition, it is clear that formula of pressure is equal to force divided by area. We know that unit of force is Newton and the unit of area is meter square. So the unit of pressure is equal to Newton per meter square. There are some factors on which pressure depends. First one, it is directly proportional to force. That is, when force increases, pressure also increases. If force decreases, the pressure also decreases. Second factor is it is inversely proportional to area. That is, when one quantity increases, the other quantity will decrease. That is, when area increases, pressure is found to decrease. Now let's check out the daily life examples of pressure. Do you know why your school bags provided with wide straps? We know that pressure is equal to force divided by area. That is, pressure is inversely proportional to area. So, if area is more, less will be the pressure exerted. So, it is very comfortable or it is very easier to carry bags with a wide strap. It is easier to hammer sharp nail. We know that pressure is inversely proportional to area. Therefore, less is the area, more is the pressure exerted. Hence, it is easy to push the nail by the pointed end than by its head. So, it becomes very easy to hammer sharp nail. Camel can cross the deserts. Camels have broad feet so that foot area is more. From the definition, you know that pressure is inversely proportional to area. So, if area is more, there will be less pressure. So, camel exerts less pressure on the ground. Fluids. Fluids are those that can flow, for example, liquids and gases. Fluid pressure. It is the pressure exerted by fluids. That is, if the pressure is exerted by the liquids, it is termed as liquid pressure. There are some properties of fluid pressure. Pressure decreases with height. Do you know why do climbers take oxygen cylinder along while climbing heights? Atmospheric pressure decreases with height. Therefore, oxygen available for breathing is comparatively less. So they have to take oxygen cylinder along while climbing height. Pressure increases with depth. Liquid pressure increases with increase in depth. Pressure is high at bottom. Therefore, deep sea divers have to wear special suits to protect themselves from high pressure. Pressure applied at any point is equally transmitted in all directions. Take a round bottom flask with holes. This flask is then filled with water and then connected to a movable piston. When piston moves downward, the water flows out through all the holes. This implies that pressure applied at any point is equally transmitted in all directions. Let's do some activities to prove this. Activity to show that pressure increases with depth. Take a plastic container. Make 3 holes at a different height. Put the container under a tap as shown in the figure. Observe the force with water flows out through all holes. It is observed water flows with great pressure from last hole. It shows that pressure increases with depth. Activity to show liquid exert pressure at the bottom of container. Take a tube of approximately length 15 cm. Take a piece of good quality rubber balloon. Stretch the rubber balloon over the end of tube. Hold the pipe in middle at vertical position as in the figure. Now pour the water into it. You will notice balloon starts bulging. As more and more water is poured, balloon bulges more. This implies that liquid exert pressure at the bottom of the container. Activity to show that liquid exert pressure on the walls of container. Take a plastic bottle. Fix cylindrical glass tube near it as shown in figure. Stretch the balloon on the mouth of tube. Now fill the bottle half with water. The balloon starts bulging. It shows that pressure is exerted on the walls of container. Activity to show that liquid exert equal pressure at the same depth. Take an empty plastic bottle. Drill 4 holes near bottom at same height. Now fill the bottle with water. Observe the streams of water coming out. Water flows with the same pressure. This activity shows that liquid exert equal pressure at the same depth. Activity to show gases exert pressure on the walls of their container. As you inflate a balloon by pumping in the air makes the balloon expands by exerting pressure on the walls of the balloon. Now if you open the mouth of an inflated balloon, what do you observe? You feel the air comes out of the balloon very fastly. This is because the air comes out with pressure. If you try to inflate a balloon having holes, are you able to do so? No, it is because air exerts pressure on the walls of the balloon and leaks out of the holes, and hence the balloon does not get inflated. Atmosphere. We know that air is all around us. Atmosphere is the envelope of air around us. It extends up to many kilometers. Troposphere, stratosphere, mesosphere, thermosphere, and exosphere are the regions of atmosphere. Atmospheric pressure. It is the pressure exerted by the atmosphere. It can be measured by instrument barometer. Do you know why rubber sucker sticks to the wall when it pressed against the wall? When we press the rubber sucker, most of the air between surface and rubber escapes out and sucker sticks to wall due to atmospheric pressure acting on it. To pull it back, one needs to apply certain force which should be enough to overcome atmospheric pressure. Do you know why our bodies do not get crushed due to an intense atmospheric pressure? It is due to pressure inside our body. There is blood inside our body, there is blood. This blood exerts some pressure. This pressure is just equal to atmospheric pressure and balances the pressure from outside. Thank you.